Okay, welcome. We're now going to solve a kinematics problem. Let's read through it. A runner accelerates at a rate of 4 meters per second squared for a certain amount of time. So they're giving us the acceleration, but they're not giving us the time. Then she maintains a constant speed for 120 meters. We don't know what that constant speed is, but we do know the distance is 120 meters. Then she accelerates at a rate of a. We don't know the acceleration, but we know that the time is 3 seconds. Finally, she finishes the 200-meter run with a final speed of 18 meters per second. So that's the final push of the sprinter. She finishes, the total distance is 200 meters. Her final speed is 18 meters per second. The problem wants us to know what is her acceleration A, how fast did she accelerate during the final stage of the race, and what is the total time for the race. Okay, so this kind of kinematics problem gives you some unknowns and doesn't give you some unknowns and is asking for those unknowns. So the first thing we want to start out with is draw a picture, see what we know, what we don't know, and then we start using the equations of kinematics. Okay, so let's draw this one here. Even though the problem doesn't tell us explicitly that the initial velocity of the runner is 0, we assume that the runner is starting initial velocity is 0 and then picking up speed from there. So the initial velocity is 0 here, and acceleration is 4 meters per second squared for a certain amount of time. So we don't know that time. So acceleration is 4 meters per second squared. T is unknown. By the end of that time, the sprinter, the runner, has established a certain velocity, right? V final, which becomes your initial velocity during the next stage of the run. So that V final is V initial. And then she runs for, what are we given? Basically, she runs for a constant speed, a constant velocity of 120 meters. 120 meters, that's this distance. 120 meters, okay? Then what are we told? Then she finishes then she accelerates at a rate of a. So her initial velocity here is the same as the velocity that she has during that race, right? So her initial velocity is the same, and then she accelerates at a rate of a. We don't know that. We don't know a. A is unknown, but what is given to us? The time is 3 seconds. Time is 3 seconds. So over here, we don't know the time, but we know the distance. Over here, we don't know the time, we know the acceleration. And then what else do we know? She finishes the race with a speed of 18 meters per second. So we have the final speed. And then we also know the total distance for the race is 200. The whole thing must be equal to 200 meters. So how can we put all of this together? Okay, using the equations of kinematics, we can find out the distance that she would have covered in the first stage. X final is equal to X initial plus V initial t plus half AT squared. So we use the second equation of kinematics, right? Her X initial is 0. Her V initial is 0 over here, starting out. The acceleration is 4. The t is unknown. So X final would be half of 4. T is unknown. So we get 2t squared. That's going to tell us what? Depending on the time, this is the distance that she would have covered in the first stage. So we can just call this D. D1. That's this distance right here. D1. What would her velocity have been at the end of the t seconds if she accelerated at 4? So we could use this equation. V final is V initial plus AT, right? Her V initial is 0. What's her acceleration? 4. What's the time? T. We don't know T. So her final velocity here is 4t. Okay? So this takes care of how much we know, how much information we know about the first stage. Let's go over to the second stage now. In our second stage, we know that she's just basically running at that same velocity, v final is the same as v initial, and we just can call it v, right? Same constant velocity for a distance of 120. So if you're going at a constant velocity, your distance in the second stage is equal to the velocity times time. That's the only equation for constant velocity. The distance you're traveling is your velocity and your time. The distance is 120. So basically, what do we know? The final velocity is equal to what? This is the velocity here. It's equal to this final velocity for t. The t is unknown, right? We don't know this t either, right? So let's put subscripts here. This is t1, right? This is the time for the first stage, okay? Do we know how long the second stage took? No, we can call that t2. We don't know t2 either, right? So this is the time for the second stage. Okay, so the equation just becomes the distance traveled in the second stage is equal to the velocity that you were going at in the first stage times the time for the second stage, which we don't know. So 120 is equal to v. V is equal to 4t. We're going to put t1 here, right? This is the time for the first stage. We put that into there. 4t1, t2, right? So this is 4 times the t1. We substitute it. So that means the product of t1 and t2 is equal to what? 30. That's it. Now let's go over to the third stage. Okay? The distance that you cover in the third stage is what? So let's use this equation again. V initial t plus half a t squared. V initial t plus half a t squared. Okay? This is the distance in the third stage. Right? What is your V initial? Here is the same as the constant velocity that you were running over here. Right? So that's your V initial. So for V initial, we're going to put the V final for T1. What's going to be T? This is T3. Right? This is the time for the third stage, but the problem has already told us the time for the third stage. It's 3 seconds. Right? So we put here 3 seconds and 3 seconds, but we don't know the acceleration. Right? We don't know this A. So I'm going to take V initial here, substitute it for T1 into here. Okay? So we have 4T1. What's T3? It's the time for the third stage, which is 3 seconds. What's A? We don't know A. You see? What's T3? Again, time for the third stage, 3 seconds. So what do we get from here? D3 is equal to 3 times 4, 12T1 plus 9 over 2A. Okay? So I'm going to circle all these equations. This one. We have this one. Okay? And then we have this one. And we have this one. Okay? What other thing do we know? We know that the final velocity that you're going at is what? V final is V initial plus AT. Okay, so what's the final velocity? 18. What's your initial velocity here? Well, it's again the same thing as the V final. So that would be 4T1. So V initial is 4T1. What's A? A is unknown. What's T? T is the time for the third stage, right? So whatever initial velocity you had here, plus the acceleration, plus the time of the third stage, so this is 3 seconds. So it's just going to be 3A, right? We can just put 3A. So over here we have 18 is equal to 4T1 plus 3A. What else do we know? The distance of the whole run is 200 meters. So D1 is this distance, plus second distance is 120, right? Plus the third distance, d3, is equal to what? The distance here plus this distance equals to the total distance of the race, 200. So therefore, d1 plus d3 equals to what? 80. Okay? So we can get an equation from there. So let's erase this one here. Go to 80. d1 is 2t1 squared, right? That's this one. What's d3? d3 is this one, right? Plus 12t1 plus 9 over 2a. So this one was the distance in the first stage. The sum of these two are the distance in the third stage. And then the second stage was already given as 120. So this is going to be 80, right? So this is going to be d1 plus d3 is equal to what? 80. Now how can we solve this?